All right, for this problem, we're asked to approximate the area under the curve y equals x squared from x equals 2 to x equals 4 using a right endpoint approximation with 4 subdivisions. All right, so since we're using 4 subdivisions and we're going from x equals 2 to x equals 4, each of those subdivisions is going to be half a unit long. So let's start by plotting some points. So if we're going from x equals 2 to x equals 4 by halving half unit increments. So next would be 2.5, 3, 3.5, and then 4. And so if x is 2, then y, which is x squared, would be 4. And then 2.5 squared is 6.25. 3 squared is 9. 3.5 squared is 12.25. And 4 squared is 16. So let's graph this and see what it looks like. All right, so we'll go 1, 2, 3, 4. And then up the side, 2, 4, 6, 8, 10, 12, 14, 16. All right, so we know that when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. And when x is 4, y is 16. Oops. So we're going to get this parabola, kind of looks like that. All right, so now what we're trying to do is we're trying to estimate this area from 2 to 4 between this curve and the x-axis. And we're going to need calculus in order to find this exactly. But for right now, what we're asked to do is estimate this. And we're really good at finding the area of rectangles. Rectangles is just the length times the width. So we know that if we're going in half unit increments, that the length of each of these rectangles that we're going to create is a half of a unit. And since we're asked to find a right endpoint estimation, that means we're gonna use the height that would correspond to the right side of each of these rectangles. So for this first rectangle from 2 to 2.5, we're going to use the 2.5, the x equals 2.5 side of this. So when x is 2.5, y is 6.25. So this first rectangle is going to look like this. And the area of that rectangle is going to be 1/2 times 6.25. So 0.5 times 6.25. And then the next rectangle is going to, again, be 1/2 a unit across, and its height, we're going to use 3, since that's the right side of this rectangle. When x is 3, y is 9. So up here at 9, we're going to get a rectangle that looks like that. And the area of that rectangle is going to be 0.5 times 9. And then we keep doing that at 3.5. It's 12.25. And we have a rectangle that looks like this. And then at 4, we're going up to 16. And so the areas of each of these rectangles are 1/2 times 6.25, 1/2 times 9, then 1/2 times 12.25, plus 1/2 times 16. And if we add all of those up, we're going to get a total area of 21.75 square units. And you can see that this is an overestimation, but you can also see that if we were to make more of these, so instead of 4 rectangles, we made 8 or 16 or 32. The more of these we made, the closer we would get to an exact approximation, and that is the whole idea behind the Riemann sums that we're talking about as we introduce integrals. All right. So 21.75 square units.